Okay, guys, welcome back. Today we're going to be talking about some of the weird stuff that water does. I don't know if you guys have ever really thought about it, but water does some unusual stuff. Like, have you ever thought about why ice floats on the surface of water? Or maybe why water can dissolve so much stuff? So we're going to talk a little bit about that, and a lot of it has to do with that hydrogen bonding that we talked about in the last lesson. Okay. So hydrogen bonding. We know that water has oxygen and hydrogen in it, okay? So because oxygen is so much bigger than the hydrogen, it has like 8 protons in its nucleus, it's able to attract those electrons a lot more often than the hydrogen are. So it has slightly charged regions. It's not like super big, it's just that oxygen's a bit more negative and the hydrogen's a bit more positive. So polar molecules do this. Water's polar, but non-polar molecules don't have this. They don't do this. They don't have this charge. So like oil, think of things that don't dissolve in water. Those are non-polar. So hydrogen bonds form between the negative and the positive, and I've got a diagram on the next page. So hydrogen bonds occur because the positive hydrogen wants to stick to the negative oxygen. So again, don't really bother with these numbers. That's if we're using the guided notes, but we're not doing that right now. So these little bonds right here, these are hydrogen bonds. So water tends to bond to itself. That's going to be super important in a minute. So there are 3 main properties of water that we have because of hydrogen bonding. So high specific heat, cohesion, and adhesion. So you see in these test tubes here, on the left we have colored water, and on the right we have mercury. And I don't know if you know what mercury is. It's the dangerous stuff in thermometers. Like if you break a thermometer, everyone's like, oh my gosh, and you have to clean it up. It's a toxic metal that's actually liquid at room temperature, which is kind of cool. Water tends to stick to the edges of a test tube, whereas mercury doesn't want to touch it, so it's repulsed. So this is, we'll talk about this in a second actually. So specific heat. This means the amount of energy that it takes to raise 1 gram of a substance 1 degree Celsius. So water has a high specific heat. This means it can absorb a lot of energy. This is because water tends to stick together, so it takes a whole heckin' lot of energy in order to make water do anything. So like when you boil water, it takes a minute, right? That's because you're having to add enough energy to overcome all of those hydrogen bonds and make it basically turn into a gas. That's what's happening when you're boiling water. So this also is why we have something called evaporative cooling. That means like your sweat or something like that, when you get water on you and it evaporates, you cool down. That's because of that specific heat. It's absorbing, like the water's absorbing that heat so it can evaporate. That's also why if you live closer to water, the temperatures aren't as extreme, which means if you live on the ocean or by the Gulf, you tend to have cooler summers and warmer winters than people further inland might. That's also why, like when I walk near the levee near my house, it feels different than when I'm more, away from the levee, because you can feel the river drawing that heat off of the land. It's kind of cool. Okay, so cohesion. Water molecules tend to stick to other water molecules. So think like a family that is cohesive sticks together. You might have heard of that word in that context, a cohesive family. So this is how we get something called surface tension. So if we go back for a second, so high specific heat was how we get, evaporative cooling and boiling water and all that cool stuff. Cohesion is how we get surface tension. This is how boats work. Because water tends to stick together, that is why a boat can like sit on top of the water without sinking. It wouldn't be able to do that the same way in, say, a swimming pool full of alcohol or something like that. But you can see this is one of those pond skater bugs. You can see where it dents the water just a little bit, but it's not able to break the surface tension. So it's almost like a skin on top of the water, just the water molecules sticking to each other. So these little water skater bugs are able to do that. They can just glide on the surface of the water as long as they don't break surface tension. A lot of bugs do this. It's a little morbid, but this is actually why if you've got a wasp in the house, you can put soapy water in a jar. They can only swim and get on top of the water because of surface tension. And if you break surface tension with soap, the wasp can't get out and it drowns. That's some weird fact that I know because of my mother. How about that? Okay, so adhesion. Water sticks to other things. So because of its polarity, water can stick to other surfaces and objects. So this causes something called capillary action, where water sticks to the sides of a tube and resists the pull of gravity. So the water is able to climb up just a little bit. So the next time you get a drink with a straw in it, if you look really close, you'll be able to notice the level of water in the straw is just a little bit higher than the level of water in the cup itself. And that's because adhesion is taking place. That water is sticking to the sides of the straw. So we see with these capillary tubes, they used water and mercury again. So the water is able to stick to the sides and pull itself up, whereas mercury, it doesn't stick to the sides. It actually does the opposite. It doesn't want to stick to the sides at all. So it's actually lower than the level of the liquid, which is kind of cool. And trees use this because trees don't have a heart. How else are they going to get water all the way up to those leaves? I don't know if you thought about that. How do they do that without a heart? And they do that because water sticks to the sides of tubes. So they're able to get water all the way up there. Okay, so a lot of things can dissolve in water. We know that. Like when you go to clean up a mess, you usually get water to do that because water, you can use that water to dissolve whatever dirt or anything is there. But what happens if you've got, say, an oily mess, right? It's hard to clean that with just water, isn't it? You got to use soap. You got to use something else. So yeah, not everything dissolves in water, but a lot of things do. So we can get something called a solution, which is a homogeneous mixture formed when one substance dissolves in another. So a solution, it's not going to like dissolve out. So like if you have contacts, your contact solution, it generally doesn't settle out into like contact powder and water. It's usually whatever mixed together. Salt water, you mix it together, it'll stay salt water until you evaporate all the water out. So this is going to be on your test right here. I'm going to tell you this right now. So a solvent dissolves other substances, and a solute is the thing that's dissolved. So the way I think about this, nail polish remover with acetone in it, that's a solvent, okay? I'm using that acetone to take off my nail polish. Or in an automotive shop, when you're trying to use a degreaser, that is a solvent. It is dissolving that grease, okay? A solute is the thing being dissolved. So in here, we're dissolving like red food coloring or whatever in the water. So the water is the solvent. It's surrounding the solute to dissolve it, okay? Take a deep breath, let that sink in. Okay, so like tends to dissolve like. So polar solvents dissolve polar solutes. So I can clean up sugar and salt or most dirt with water because it's polar. Non-polar though, like oil, I need a non-polar solute. So you might need, I don't know, something like an alcohol or a different kind of solvent to do that. So like the water won't take off your nail polish, but acetone will. You need a different solvent for that. and polar and non-polar substances generally remain separate. This looks a little gross. What it is a magnified image of what's going on in salad dressing. Like you get the bottle of salad dressing and it has the layer of oil on top because the oil doesn't mix with water. You know that. But to kind of mix it together so you can use it, you gotta shake it up, and you know there's like little bubbles in it. Well, that's what that looks like when you zoom way in. So these yellow bubbles, that's the oil, and then the clear stuff, that's the water. Okay. One other thing we need to talk about today is pH. Okay, we talk about acids and bases. So an acid releases hydrogen when it dissolves in water. So it has a high hydrogen concentration and it's any pH less than 7. I promise you, you're gonna have to know a little bit about this on your test. So less than 7 is an acid. If you're taking notes, you might wanna make a little number line, and anything before 7 is going to be acidic. And the lower the number is, the more acidic it is, and the higher amount of hydrogen it has in there. So like battery acid, you know, is super corrosive and you're not supposed to touch it with your skin. So car guys have to like wear gloves and stuff when they work with it. So it'd have a really low pH, whereas vinegar's not gonna burn your skin if you get it on there. Like if you accidentally get your salad dressing on your hand, you're not gonna have some big sore on your hand or something. It's like, it's just whatever. So it's gonna have maybe more like a 5 or a 6 pH. Okay, so neutral has a balanced hydrogen concentration and a pH of 7. Most organisms need to keep their pH near 7. It's okay if it's a little below or a little above, but around 7. So pure water is pH 7. So you gotta know that. You gotta know where neutral pH is. You're gonna be tested on that, I'm just saying. Okay, and then a base removes hydrogen ions from a solution. So it's a lower hydrogen concentration. So it's a pH higher than 7. So bile, that's like part of your digestive juices, not stomach acid, because that would be a low pH, right? Bile enters your digestive tract later, like your gallbladder, you know? So also baking soda, that's a base. So that's why like you add, you know, the vinegar and the baking soda and it makes the bubbles or whatever. Yeah. Okay. So I think that's everything. Please let me know if you have any questions. Today you have a web quest on the properties of water. Please make sure that you are completing it and filling it out and turning in your work. I noticed that some of y'all are turning in blank assignments. Please note that you're getting zeros for everything that you click submit on without, you know, actually doing the work. I'm not just looking, oh, you turned it in, she's getting her points. That's not what we're doing. So please do your work. I assign it for a reason. I'm trying to help you all learn this material for the test, okay? So like I said, let me know if you have any questions or any problems getting any of the things to work, and I'll see you guys in the next video. Take care.